David Eisenberg works for Net Identity now, but in 1997 he worked for AT&T Labs. No. That's what's on your thing. Eisen.com, excuse me. Okay, it says Net Identity in the thing for some reason.
Sorry.
Okay. He works for Eisen.com, which is himself. In 1997, worked for AT&T Labs, where he wrote a paper called The Rise of the Stupid Network. Those of you who've dealt with telcos, worked with telcos in the past, know that they talk about the intelligent network, which provides every service that every user could possibly want. You plug in your stupid telephone, and it does things for you. This is kind of the opposite viewpoint, which maybe wasn't met with the greatest reception from what we affectionately call the bellheads, but it kind of defines what we do for a living. So you could expect perhaps that what you might hear here will be interesting, maybe a little controversial, hopefully a lot of fun, and definitely discussion provoking. So without further ado, David, good morning and welcome.
Hello.
And I'll push your button.
Let's see. There we go. Hi. Hi? Okay. I am really intimidated to be talking to you guys. You know, I'm supposed to tell you about the internet. Sorry, I don't think I can do that. Especially that special part of the internet that lives at layer 3. I never knew there was so much at layer 3. I always thought that was the thing that made the internet stupid, was layer 3, and I find out, boy, am I wrong. So what I think about a lot more, I haven't written a line of code or done a technical job in over 10 years. I left Bell Labs 10 years ago. But what I do tend to think about is the intersection of corporate culture, business models, and economics and regulation and stuff like law, stuff like that, as it affects the internet and networks in general. And I had to look speaking of corporate culture, I had to look no further than this hotel last night to see how permeating the culture of the local corporations are around here. I was sitting on my bed trying to change the channel on my TV, and I went push, 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 push. Oh, and then the channel changed, and then it'd go push, 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 and the channel would change. And I went, man, this thing needs batteries. So I called up, and the engineer came up, and the engineer tried to convince me. He said, this TV isn't like your TV at home. It has special features. And so and then, so then I said, no, could you please change batteries? And it would push, 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 push. And it still didn't work. And he went, well, you have to push the button really carefully like this. And he walked right up and pushed the button. And I could see that he was still pushing it 3 or 4 times to get it to change. But so then I said, look, could you please fix it? And he went, well, I need to talk to my manager. So 5 minutes later, the phone rings. I picked up. This is the manager. And I said, well, the TV's broken. He said, well, the TV has certain issues. Okay. So, but I have to say, Bellevue isn't just the Microsoft culture. I mean, I walked into the Apple store across the street, and there was a woman breastfeeding, and I could smell the funny smoke wafting out of the back room. So multicultural. Anyway, so you probably have all heard about network neutrality, and if you think of sitting there and tweaking BGP or whatever it is you guys do, installing the router, selling the router. If you think of that as just a regular job, then this talk won't be really too interesting to you. But if you think of it as, this is my passion, my life, this is why I exist. I'm surfing down the biggest wave of history right now because the internet is special and wonderful. Then this talk is for you. And in fact, if you're not sure, I'm here to remind you that the internet is special and wonderful and completely unprecedented in human history, even though there are parallels. History doesn't repeat, Mark Twain said, but it rhymes. The whole talk revolves around two antithetical questions. We netheads ask, how do we change network service provisioning so the internet survives? Because the internet is actually in deep danger right now. Once upon a time, radio used to be primarily an amateur medium. Now it's been totally corporatized, and 3 or 4 radio stations, station companies own all of radio and TV. And newspapers used to be completely amateur and democratized, and now just a few large corporations own most of the newspapers. Sure, you can find amateur radio if you look in the corners, and sure, you can find amateur publications if you look in the corners and go to the offbeat bookshops in university towns. But, and we face the clear and present danger, but it's true, we face the clear and present danger that the really cool stuff, the democratizing stuff about the internet, the self-expression, all that, is going to be pushed into the corners, into the free speech zones with barbed wire around it that are out of the mainstream, where sure you can have free speech, kid, just don't bother us with it, okay? So there really is a danger. So there's two different questions on the table for those of us who are paranoid enough to, and that's not necessarily a bad thing, ask Andy Grove. Those of us who are paranoid enough to believe that the internet is in danger ask, how do we change service provisioning so the internet, as we know it and love it, survives and doesn't get pushed into a corner? Meanwhile, the telephone companies and cable companies who are legitimately feeling threatened and pushed into their own corner go, how do we change the internet so we survive? And these are two incompatible positions. Is there a compromise? Maybe. I haven't seen it yet. There is a common problem, and that is the creation of operating models that give us a stable, sustainable internet, where all the good stuff is preserved. Now, the internet is better than the broadcast networks, the telephone network, the cable network, because it's a general purpose, any app over any physical medium network. It's better than application-specific networks because it allows for, I don't need to really tell you this, it allows for application discovery. Put code on the net, send it to your friends, try it out. If you like it, use it. Maybe other people use it too, okay? But then Market discovery, you find out who else wants it. And this, you have the application without permission. People know about that, talk about it all the time. But market discovery, I think, is more important. It's totally slippery, low-cost way of finding a market that you didn't even know existed before. And that's because the locus of control is at the edge. No hierarchical corporation has to decide on a business case for, say, YouTube, which happened to work, even though Google Video and all those other things didn't work so well. What was the magic sauce? Well, I'm not a close enough student. Will there be others? You bet there will be, unless we change the locus of control so that there are barriers to what you can put on the internet. And the first step in changing the locus of control is, oh, this application fits in this silo. That application fits in this silo. Oh, here's a new application. Which silo? Oh, it doesn't fit. Oh, application not recognized. So we don't want that. We netheads don't want that. And I'm not even going to read these. I've said it already, but it's been a miracle. It will continue to be a miracle. The telephone companies created, and they knew about all these markets and all these applications, but they didn't bring them to market. We did. Because we could just put it out there without permission, without gatekeepers. I don't mean SIP, I mean political gatekeepers. And let's not forget that the internet is about more than just commercial applications. It's about freedom of speech, freedom of the press, freedom of association, routing around censorship, and many of the other derivative freedoms. If you look at places that aren't free, that are run by fundamentalist governments, Egypt, Iran, Myanmar, China, internet censorship. And it's more than just freedom. Charlie Nesson, who's the founder of the Berkman Center for Internet and Society, even says there's divinity in it. And I don't think, I'm an agnostic, atheist, whatever. I don't think he's wrong. So you guys probably like to see data. Here's some data collected by physicists. But basically what that says is that packet losses are decreasing approximately 1 order of magnitude every 5 years, which is approximately Moore's law. And it's doing so over all different kinds of networks and all different kinds of circumstances. The internet is just getting better, folks. Here's another one, TCP throughput improving by about a factor of 10 every 5 years in accordance with Moore's law. Leave it alone and the thing gets better. Of course, you guys wouldn't say, leave it alone, my ass. We're doing it. And in fact, that's true. But, and that's good. So, in other words, the internet is doing real well. It's growing without limit as far as we know. It's getting better without limit as technology allows it. Nobody owns it. People own pieces of it, but we don't even, people who own pieces of it don't even know what the rest of it is or where it is. Nobody plans its growth. And there's no business model or return on investment or any of that crap. In other words, it is everything that the telephone company isn't. The telephone company and the cable company and the cell phone companies, they limit growth. They want to sell. If things weren't scarce, they wouldn't have anything to sell. They strictly gate the technology based on depreciation schedules. They own it and they damn well know what they got. They plan very carefully how it grows to the percent. At least they did until the long hold times for the dial-up internet evolved. Then they go, and they have this, you know, they've got these business models tuned out to the umpteen percent. So here's the big accident, and that is that the people who bring us internet access are the people who are most threatened by the internet. Okay? So with the graphs I showed you about improvement, those were the core, but the edge has big problem. Places where it's allowed to grow with technology, where the telephone companies have been deliberately restrained from restricting it, like Japan and Hong Kong and places. You get 100 megabits for $30 a month, symmetrical, growing to gigabit, 10 gigabits, 40, you know, I mean, it's, but here they're still selling scarcity. And the reason is that they're threatened. They're losing their butts to, well, they're not, they see that they're afraid they're going to lose their butts to Skype, YouTube, you know, views, all those applications that used to be built into the very center and essence. They didn't call them telephone poles for nothing. They were vertically integrated pieces of the network. So, back in 1993, I had a very perceptive office mate at was it 93 or 92 even? He said, if AT&T knew what was good for it, it'd kill the internet. As if AT&T, A, knew what was good for it, and B, could kill the internet, if they did. But actually now, Dave Clark of Salzer, Reed and Clark, MIT professor of computer science, said the internet can't root money in 1997. He was referring to the same problem. And then Dave Dorman, who was the last CEO of the real AT&T, the one who brokered the deal to sell to Bell South and got paid handsomely for it, said email's a feature that, email, web browsing, these are all features that nobody pays for and we have to carry them. Well, we need network resident applications. Well, by 2003, in other words, they were finally starting to get what Ed Whittaker became famous for in 2006 when he said, they're not going to use my pipes for free. So the telephone companies, meanwhile, not just because of the internet, because, well, they ramped up the capacity to deal with the dial-up internet. They put a lot more dial-up ports and they increased the hold times in their model. And then the cable companies started offering fast access that wasn't dial-up. And the reason the cable companies went zooming ahead wasn't because DSL was an underdeveloped technology. It was because the telephone companies were sitting on their hands and waiting for the extra voice ports that they put in to support the dial-up internet to depreciate. And they didn't depreciate fast enough. Anyway, so the telephone companies sold a lot of second lines for internet and for fax, and then along came the cable companies with their fast internet access. Along came the mobile phones and people started the second line stopped growing and started falling off. And now people are even abandoning their first lines as Skype and Vonage and so on are coming along. And so if you project sort of the last few data points, and I have to say this is a year old. I was lazy and didn't update it before I came. But the 80% intercept is well within, and that's, you know, if you, I can wave my arms, 80-20 rule, okay? 80% of the customers generate, or 20% of the customers generate 80% of the revenues. The top 20% are most likely to be abandoning first because they're heavy users, early adopters, et cetera. And so by 2011 or 12, the telephone company landline business will be defunct. It'll still be going. There'll still be copper loop, but they're in trouble and they know it. By now, they really know it. Okay? They also see this. This may be motivating them more. Here's the market cap of Verizon versus Google. Okay? And Verizon's is going down and Google's is going up. So and they see that. They have market cap envy. So the carriers, starting in the late 90s for sure, but they really got serious in 2003. And in 2003, after, you know, as they were digesting the telecom bust, they went to the FCC and they said, the only way we're going to put in fiber is if we don't have to share it. Fiber in the local loop. FCC said, fine. Then there was the Brand X decision, which decided whether cable modem access to the internet was a telecommunications service or an information service, and they decided, the Supreme Court decided in really twisted logic that it was an information service, even though the definition, if you read a common sense definition, it would say exactly the opposite. Lower court said it was that the connection part was a telecommunications service, but nope. So Brand X privatized cable, and then a few weeks later, Kevin Martin said, well, gee, the telcos need a level playing field. In fact, if you look at Kevin Martin, the head of the FCC, everything he says about innovation is about the ability for telephone companies to innovate so they can do what cable do. That's it. That's how Kevin understands innovation. So, once again, two different questions. We netheads ask, how do we change network service provisioning, specifically internet access, so the internet survives? And the telephone companies are saying, hey, what about us? We want to survive, even if we have to change the internet. And the common problem still is the sustainable internet. So in 2006, shortly after Ed Whittaker's famous, they ain't going to use our pipes for free statement, Free Press and Move On, and a bunch of other more bipartisan organizations took up the cause of network neutrality. Network neutrality is prohibits internet access service that treats different traffic differently. Neutrality says you treat all the traffic on a level playing field. So by the end of 2006, we won this great victory, limited great victory, battle great victory, not war great victory, but the victory was in the AT&T Bell South merger, we got language in it that said that for 2 years, the merged AT&T Bell South wouldn't provide internet access service that privileged, degraded, prioritized any packet based on its source, ownership, or destination. That's a pretty good definition of network neutrality. And here's another one that the telephone companies offered. We won't block, impair, degrade content, applications, or services. That was said by Walter McCormick in Congress in February of 2006. But he said, but we don't need a law. Trust us, we don't need a law. But the internet he also said, the internet that you have today will be the internet that you get tomorrow, which is just fine unless you realize that the internet that we had yesterday ain't the internet we got today. It's dynamic and moving and expanding and improving. So, and I say that network neutrality, it's about the absence of deliberate anti-competitive action by the carriers. So here's an old slide that I've had in my computer for 10 years. When you have a network of different networks, it pushes the value to the edge. You used to have the intelligent network with the value in the middle. Well, when you have a network of different networks, there's this lowest common denominator thing happening, and so in the old way, SS7, when you set up a call, it touched every node in every network, so any network owner was free to add cool features to their network so that it would be more competitive than a competing network, bad old network D. As a result, people would favor network C. But when you have a network of different kinds of networks, the cool features, any network-specific difference, you want to ignore it, route around it. You want to do the lowest common denominator, which is just deliver the bits. Stupid. Now, I know it's more complicated than that, but if you're looking down on layer 3 from the application, I know you guys are doing the magic on layer 3, but when you look down on layer 3, the layer 3 provides a clean interface embodied in the IP header that, you've got this really nice little tightly well-defined thing, and anything goes. So I want to stuff Coke bottles into the payload of my packet. You guys don't care. And maybe I'll discover a market for Coke bottles. So, but what this slide says is that the old paradigm of adding network-specific features, such as call waiting, caller ID, stuff like that, those become totally obsolete and even interfere with the idea of value at the edge. So the stupid network is a neutral network. I'll say it another way. Stupid network supplies simple connections, and the services are all created by network-enabled products designed for whatever network application you want, and you just bring them home and plug them in. I just like the graphic, I'm sorry. I know I'm repeating myself. Here's the business view of this, the old telephone company paradigm. They sold the application, the ability to make a telephone call is what people bought. They didn't buy explicit, they didn't buy a share of the wire or a piece of the telephone pole or a piece of the switch in the central office. They paid for the ability to pick up the phone and call someone. So, but that application, because it was connected to a telephone, which was connected to telephone wires on telephone poles that went to a telephone switch that went into a telephone network, it subsidized the wired-in network resident telephony application. Same with cable TV, by the way. And the other stuff, the fact that they provide internet access, is an accident. In the new paradigm, the application can be anything, any app, over any network. The network layer provides what's called a portability layer, and the physical layer is the any network part of any app, any network. And we know that people will pay for this stuff, and if they won't pay, then advertisers will pay for it. No problem with applications. People love applications. They buy them all the time. They use them all the time. The network layer, you guys live there. I call it a commons, but I know there's a whole ecology there. But there's a big question about how that physical layer gets provided in the future. Because if the telephone companies and cable companies and cellular companies who are used to having these vertical apps provide just raw connectivity, that's a completely different business model. And companies don't change business models midstream. IBM is the only large company I know that ever did it, and they did it in a near-death experience kind of way. But it's almost like 98% of the bacteria in the Petri dish died off, and then the 2 mutants managed to repopulate the Petri dish at IBM. That's pretty much how it has to work. So, and it's hard to make money on stupid connections. The middle of the network is empty. The stuff that used to be scarce is now plentiful. There's guys out there selling 55 gigabit boxes. I've got a gig connection on my Mac. You know how much a gigabit is? A gigabit is enough to serve the conventional telephony needs of a city of 100,000 people. So 10,000 is 640 megabits at 64 kilobits. So a gig is enough to serve 100,000 people. So then you have, 40 gig on a wavelength, and you've got 100 wavelengths on a fiber, and 864 fibers in a bundle. And I did a back-of-the-envelope calculation, and I figured if all 6.5 billion of us were off hook generating 64 kilobits, and all that traffic came to this 864 fiber bundle, there'd be 100 dark fibers. So, and so we're not bandwidth limited anymore. The stuff the telephone companies sell has to be, they have to figure out how to make it artificially scarce, because in fact, it's not scarce. So, so the carriers attempt to fix the business model by, putting Humpty back together again, putting the air in the balloon, the toothpaste back in the tube, and they're using, they're making all kinds of excuses: application awareness, contingent routing, tiered pricing, port blocking, watch out for spam, terrorists, drug dealers, child porn, but the real deal is they're facing the loss of their business. Nothing to sell because it's too damn plentiful, and the applications that used to be, telephony in a specific telephone network, now it's done by 12 programmers in Lithuania. The TV guys see that same thing coming. So, discrimination, application, packet discrimination, different charges for different services. That's the way they put the services back in the middle of the network, by discriminating. Oh, this is a Skype packet. Oh, that must mean he's making a long distance call. Well, that means a contribution to the Universal Service Fund, and it means that we have to have compliance with the latest thing. Last week, the FCC issued an order that if you have an internet telephony service and it's capable of connecting to the telephone network, you've got to be compliant with the ADA, the Americans with Disabilities Act, which means that what that means is that the barriers for, hey, just try out a new app and throw it on the network, just go up. I mean, we're accreting bureaucracy around the internet. The innovation thing is gone. So let's see, I think I said this already, but yeah, so okay, here, special purpose networks discriminate automatically. If you pick up the phone and it's Verizon or Quest, or I guess here it's Quest, you pick up the phone and it's Quest, you're using the Quest application. There's no, if you're not on the internet, there's no chance of saying, well, yeah, but I want to use another telephony application. No, it's wired in, it's hardwired. And this idea of tying the application to the underlying network has a 130-year legacy. That's how they've done business for 130 years. Third thing, it's that discrimination, according to some economists, is economically efficient. And that, imagine a traffic light, okay? Imagine a traffic light. One guy sits at the traffic light and says, hey, no problem, I'll wait till the light turns green. Another guy says, I gotta go, I'll give you $1 if I can just run the light. Or, you know, really, guys in a real hurry, type A guys, give you $100 to be able to run traffic lights whenever I want to, providing there were a safe way to do it. But, so if I were a traffic light company, it would be in my interest to figure out what the willingness to pay of each car was, and rather than just have a traffic light which was stop or go, I would have all these gradations with different kinds of lanes and stuff like that, and it would get very complicated, very bureaucratic. There'd be a huge billing mechanism. People, you know, a lot of people would pay. You know, I might pay $1, you know, $10 a month to be able to have preferred service at traffic lights. But the point is, it wrecks the simplicity that's made the internet the success that it is today. So, in closing, we're faced with two brand new questions. One is, what we netheads ask, how can we change the process of internet provisioning so the internet that we know and love, the simple, stupid in the middle, intelligence at the edge, internet, how do we change service providers so the internet we know and love survives? And the telephone companies are asking a very different question. How do we change the internet so we, the telephone companies, the obsolete buggy whip guys from the 19th century, maintain our business model? And the common problem is, how do we create a sustainable global internet for all of us? So kids, don't eat this. Thank you. There are microphones, but if I've explained everything clearly, please don't use them.
I'm curious if your view is that the stupid network is a low-margin network.
Is a what?
Low margin.
Absolutely. Absolutely. If you think about that traffic light again, if you start, right now it's just, you know, it's a switch on a timer, but if you start going, this guy paid to run all lights all the time. This guy paid to just stop and look and then go. and these other people, they're willing to wait until the light turns green. Think of the bureaucracy you'd have to put in place. A, to discriminate who's who. B, to enforce it. C, to collect from the various tiers of, then what if a new kind of vehicle comes along? So yeah, the internet, because it's simple and stupid, is incredibly low margin. I just happen to have sorry. Well, you can look at this too. This is the these are the slides I didn't use. Just let it wash over you. I'll get there. Oh, there's that slide again. Come on. I'm sorry, this is not working here. Oh, there it was. Here it is, yeah. In that February hearing at Congress, this guy named Gary Bahula, who's the public affairs officer of Internet 2, you guys know him? He said some amazingly important things. So let me just read from his testimony to Congress. Our engineers started with the assumption that we should find technical ways of prioritizing certain kinds of bits. We seriously explored various quality of service schemes, but all of our research and practical experience supported the conclusion that it was far more cost-effective to simply provide more bandwidth. Okay? With enough bandwidth in the network, there's no congestion, and video bits don't need preferential treatment. And he went on to say, today our Abilene network doesn't give preferential treatment. It does streaming HD. It holds thousands of high-quality two-way video conferences simultaneously, transfers huge files of scientific data without loss of packets. Rather than introduce additional complexity into the network fabric and additional costs to implement these prioritizing techniques, the telecom providers should focus on providing Americans with an abundance of bandwidth, find the bottlenecks, and blow them up. The problems will take care of themselves. And he said, a gig E connection needs a $15 card. But if the provider insists on dividing it up into telephone, TV, etc. services, the resulting box might cost $150. So they're adding a factor of 10 to our costs to preserve their business model, but not because they're going to be giving better service. In fact, it's crummier service. Okay. Thank you. Who else? Okay.
I'll take it first.
Hi.
Hi. What you kind of described as network neutrality is actually, in my view, network ambivalence. You've shown two slides that show that the performance of the internet has increased within the last 10 years. That isn't just because we provided more bandwidth. There's been some engineering effort put into it, and when I first was going to college, my stepfather, an engineer, asked me, so what are you going to go study? And I said, aerospace engineering. And he said, so you're not going to be an engineer? And I said, well, what do you mean? I'm studying aerospace engineering. And he said, well, aerospace engineers deal specifically with performance, and that's their primary goal. And my definition of an engineer is doing for a buck what any fool can do for 100. So there's some amount of economical drivers that needs to be taken into consideration to do good engineering. Internet engineers have always strived to optimize the network. So where do you draw the line between discrimination and good engineering to optimize the network to get the most value out of it?
Really good question. Let's go right back to that traffic light. You look at the cost of regulating the traffic and the simplicity and the service provided, and then you look at the aggregate benefit to everybody, and you see whether a simple system or a complex system works better for everybody. I just showed you the most serious engineering, network engineering research effort, Internet 2, since Bell Laboratories. They went in thinking that they would need all kinds of bit discrimination technology, and they tried all kinds of things, and countless theses and master's and PhD projects have been done on quality of service and application detection and discrimination and so forth. And they were aware of all of them. And they concluded that in every case, you just find the bottlenecks and blow them up. And that's the most cost-effective engineering that can be done.
For the most part, the bottlenecks are not always just bandwidth constraints. Your services such as video, real-time services such as VoIP, require other things to be taken into account. It's not just bandwidth. You have to do things like minimize jitter, minimize latency. Those require certain amounts of engineering effort. You just can't supply just a big fat pipe and expect everything to work. Well, the traffic is not always the same. The vehicles aren't always the same. And sometimes you'll have cases where that ambulance needs to get through.
Thank you. We can take this offline, but to my limited understanding, and I admit it's limited, you can minimize jitter and latency if you are just using a few percent of a giant fat pipe, and that's more simple. But let's, we could have a vote. How many people think that there are sort of like optimizing tweaks that should be done versus big fat dumb pipe to minimize latency, jitter? I know voting is not really, but okay. Optimizing tweaks. 1. 2, 3. Okay. Okay. Come on. This is. Well, I'm gonna publish this. Okay. Optimizing. Who's the optimizing tweakers? Think that that's the most cost-effective, best, et cetera, et cetera. Okay. Now, how about the big fat dumb pipers? Okay. Well,
it's not one or the other. I mean,
I understand. I understand. Okay. You were. I know you're not first, but
no, I was just voting twice.
Most enthusiastic.
Everyone using the Wi-Fi here is enjoying differentiated services. The reason this resource here is very limited, right? This is a great place to apply these kinds of principles we're talking about. DNS and TCP SYNs go ahead of line from segments here. All of a sudden, the web works. You get to compete for the queue. You see stuff happening. It's good, as far as the head's concerned. Challenge I have in these arguments is that it's not one or the other, as you just earlier said. Yesterday, Bill Norton gave a presentation about some estimates of the kind of building you'd have to support a diurnal pattern of people browsing video sites. Huge capacities midday, followed by lulls of zeros all evening. Well, not with FEC, but you know what I mean. This underutilization means we're not using what we pay to deploy. If we're coming up against a physical limit, as Len described in some of the discussions we had about his xScale equipment, it seems as if underutilization is a very costly thing. And if we want to be big pipes, no congestion, no queuing, to take care of the QoS issues, I'm not certain with a low margin network we could ever pay for that. So this is why I'm caught. What's the solution to this?
If you're saying that the common problem is making a sustainable internet, I completely agree.
It's great to know the question exists. Now we have to start talking about how to solve it.
And how to solve it in ways that preserve what's good about the internet so far.
Right. And so
the one we know and love,
and
right?
so it's a little bit of both. It's a little bit of capacity. It's a little bit of tweaks. And what I want to propose is that the QoS stuff that we are talking about from reports from people in Abilene and experiences on I2 really don't, I believe, represent any of my own experiences using these tools. They have challenges given the hardware that they were using. Juniper doesn't have, up until recently, things with granular queuing that I thought I would find very useful. They're generally useful. They're not useful like Cisco might be. There's a lot of differentiation among vendors in support for these things. It's not uniformly bad or good across the board. A little bit can go a long way. We're not doing a lot here. We're doing just enough to make it survivable with 400 people or 300 people on a very, very constrained resource. I think this applies well to broadband access, cable, DSL, the whole bit. I don't see that neutrality can't be preserved for political application level things while the network still survives adequately. And that's not being framed, unfortunately, in our representatives talking about this. And that, to me, would be a good solution.
Thank you.
Welcome.
I think you guys probably know more than I do about that. My main concern is that the baby stays in the tub when the bathwater gets drained.
Unlike the last couple of questioners, I do firmly believe in the over-provision. If you've got a stupid network to be effective, it needs lots of bandwidth. But we had a big panel yesterday which basically shows the reality we're facing for the first time in the Internet's history, that we don't have enough bandwidth. There is no technology that gives you cost-effective, greater than 10 gig technology in the core. And for the first time, it's not going to be months late, it's going to be years late. I'd be interested to know your opinion on whether that potentially threatens the future of a neutral internet.
Good question. I'm not aware. I haven't seen those curves.
That's what worries me.
Yeah. Do you have the curves? Could I look at, could you show them to me offline?
The presentations that were given yesterday in the panel, I've got some nice graphs in them.
Good. I'm really curious to see that stuff. It'd really help me understand better what's at stake when I go and talk to the policy people. I would love to see that stuff. And my answer is that I hope that the people who would restrict the internet and corporatize it and cut it off from most of us don't use that fact against us. I mean, they are really good at using, you know, the terrorist, child porn, drugs thing, you know, whatever they can get their hands on. So
Arguably, they're trying to slow this technology down already.
And well, back when I started to give this talk 6 or 7 years ago, you could do 40 gigabits over 40 wavelengths, and now you can do 10 gigabits over 100 wavelengths and go further, or 40 over 100. But it hasn't really gone as improved as fast as it has in the past. So I'm thinking that, yeah, that there's been the telecom nuclear winter of 2002 probably took a lot of really good projects and put them on the shelf. Now I'm starting to hear 100 gigabit Ethernet. But I'd love to see the curves. Thank you. Yeah.
Yeah, this is Andy Ogielski from Renesas. Internet 2 operates under rather different business model from commercial providers. It has captive audience of state and educational institutions. It's heavily subsidized. Could you explain to us why do you think lessons learned in Internet 2 apply to the commercial world?
They were investigating how you operate a network cost effectively. They weren't investigating how you operate a business model, but they were looking at how you operate a network. So I think that there's direct applicability in their findings. It's like saying going to a university, which is heavily subsidized and not in the real world and all that, and they found a cure for a certain kind of cancer, and they're not a pharmaceutical company, but still they found a cure and it works, okay? So I think Internet, too, the findings, I'm not sure how generalizable they are. I think they're pretty darn generalizable. They're not running a commercial enterprise, you're absolutely right, but I believe that the findings generalize to the cost-effective running of networks, internet networks.
Ren Provo, AT&T, but probably not the same one you're familiar with.
No, that's another company.
Right. I would like to say that in 2003, we were definitely not sitting on our hands. Many of us were receiving the long overdue 271 relief and able to finally integrate LATAs so that we could have nationwide networks for the first time. So some of the costs that were artificial burdens were finally lifted. I think I could also state in this room that many of my peers would say that I'm in the top 5, if not #1 at capacity planning for peering. So some of the statements you made about capacity planning not happening or not being a consideration or a concern may need to be revised.
Okay.
That's probably a very 1990s view of the telco. And if anybody wants to raise their hand, they'll say that we're incredibly proactive.
Good.
Because it's the truth.
Good. If you'd like to send me numbers or supporting data, it's eisen@eisen.com. And I'd love to get that stuff, and I'd love to expand my knowledge on it. Thank you.
I just think that you're putting the wrong emphasis on the telcos of the modern era. We're very bound by some of the limitations in hardware that Keith Mitchell recognized. Where do you go from here? If you're already doing the limits of the current technology in a single location with a single peer, how do you scale that? And we're all very concerned, and it's not a terrorist threat or some other social issue that's applied. This is very real, and it's very hardware-based.
Okay. My only concern is that the telephone company doesn't behave anti-competitively when they improve their technology, that they don't put in stuff like IMS, which is designed, it loses its value if discrimination is illegal. So to the extent that I know that, I mean, my hat is off to the network operations people in telcos, cable companies, cell phone companies, wherever they are. I know that they're using their highest skill to do the best job they know how to do. That is not my concern.
Well, then please make sure that you understand we run all the data recovery models. We use every tool possible. Telcos are not ignoring the network capacity needs. That is not the case.
I'm concerned that telcos are ignoring the innovator and the citizen. But yes, I appreciate your concern. I used to be there myself.
Thank you.
Okay, so, that works. We are actually at 10 o'clock, but this is a great discussion, so I want to let it go on a bit longer. So the people in line, I'll give you another 2 minutes to get in line if you're not already in line, and then we'll have to cut off.
And I'll try and answer quickly, more quickly.
Kevin Oberon, ESNet. One problem that I see in this discussion over and over is the fact that the term network neutrality has become so politically and emotionally charged that it's become a black and white issue. There is network neutrality in terms of what I guess I will call political neutrality or commercial neutrality, and favoring one service over another because they pay us to favor them, or we like them, or we have a lot of their stock or something. There is network neutrality in terms of saying, oh, there's no quality of service allowed out there. Every packet goes through exactly the same. We don't do any real engineering on this to make the network run better. We just hope that it runs well and throw bandwidth at it. You can solve a lot of problems with more bandwidth, but you can also solve a lot of problems with good engineering. But the moment the network neutrality issue is raised, people are instantly polarized. There's the, oh dear, if we have network neutrality, the network will break. And there is the, oh dear, if we don't have network neutrality, the network will break. Those are views that don't lend themselves to compromise and frankly don't lend themselves to understanding. So I'm not sure what the solution is, but we've got to realize that there's network neutrality and then there's network neutrality, and they really aren't the same thing.
Well put. Well put. The discrepancy between anti-competitive discrimination and network management is a real one that all the proposed network neutrality laws that I've seen, they make an exception for network management. I think that's a slippery slope, especially considered that the telephone companies have, over the years, historically said, plastic mouthpiece that you put on the telephone damages their network and so on. I think that network management exceptions are a slippery slope. I have another proposal, and that is to make it illegal for people who offer internet connections to have any financial interest whatsoever in what's carried over their connections. Then we're assured that whatever they do is for network management or network optimization, and I wouldn't have a problem with it. If you're in the business of running a network, run the network and have at it, and the only restriction is you can't have a financial interest in what you're carrying. So that would solve the problem in my humble opinion. I'm sorry. I'll get to you. I don't know who was first.
Blast from the past, David. Lucy Lynch from the Internet Society.
Hi, Lucy.
Hi, David.
Jeez. Undergraduate, Honors College, University of Oregon, 1940, 50, 60 something. I don't know.
About that.
Jeez, it's been a long
Internet
time.
hippie,
Hi.
which should give you all a clue. In your arguments, you said you were going to talk about economics, and there was a word on your slide at layer 3 that, first of all, I'm a huge fan of the end-to-end principle and the globally connected internet, not just talking about America and U.S. politics and whatever. But you had the word commons at layer 3, and it is not a commons. It's a common pool. There's a huge difference. A common pool is a bounded resource that it's difficult to control, access, and ingress from, which means that somebody has to pay the cost of innovation, of capacity building, of replacement, of upgrades, all of that stuff. And somewhere in there has to be economics that supports incremental payments, subsidies, which is why Internet 2 had unbounded bandwidth, was subsidies, or something that looks like base level payments. Net neutrality is less of an issue in Europe, where there's already guaranteed base level payments for a level of service. So I think you need to rescale this argument to begin to talk about the actual economics of what everybody here does and how they stay in business, because there's no internet without that.
Amen. In fact, I looked at that word and I thought that a better word was public good rather than commons. Well, how would that strike you? Common pool? Okay. Let's, can we correspond on that? Thanks. I'd really like to follow up. Good.
Randy Bush, IIJ. I've worked for the world's largest telephone company and the fourth largest telephone company. And Ren, it really excites me to learn that the peering policies and the bandwidth decision at the peering points of the big telcos have changed to be neutral and not part of business decision and competitive policy. This is a radical change that I'm sure all of us appreciate. And you'll excuse me, but I have to object because I am wearing sandals. But of course they're with socks. I'm from the Northwest. Even though I live in Hawaii. But the cheering part of it is, in my memory from back in the dinosaur days, being one of them myself, is that most of that competitive business effort in peering and screwing one's neighbors is directed towards other telcos at least.
Wearing polka dot Vans, not sandals, but I hear you, Randy. And we have learned that if you're selling DSL or other services to consumers where you have 12 million or more, you need to keep your peering pipes uncongested, because when the DSL subscribers discover congestion, you can't replace the capacity fast enough to remove it before it hits any of the news. And none of us want that. We make more money by keeping it uncongested.
I think, okay.
Yeah, go ahead.
A number of years ago, I was trying to get capacity from Marina del Rey to Santa Monica area. Oh, I'm Walt Prue from Los Netos. And I was blown away to find out that during the '84 Olympics, the phone company had put in fiber in the area that I wanted capacity, but they pulled it out after the Olympics, and I just blew my mind.
Left the copper?
I don't know what they did, but they pulled out a perfectly valuable bandwidth so that it wouldn't be available. And the other point that I'd like to make is that we're trying to set up a metro area network, and we can't get dark fiber, even though the phone company has it. They will only sell us bandwidth by the bit instead of a dark fiber, and that's an anti-competitive approach from the phone companies, in my opinion. And I think that they should be providing dark fiber with amplifiers on the dark fiber so that we can go long distances instead of just short reach. If they gave us dark fiber across the country, we could replace the entire long distance phone company with a few fibers, and so it's against their interest to do that, but they're standing in the way of progress, in my opinion.
Thank you.
Joel Yegley. I'm currently with Nokia. So I've been paying local access monopolies as a consumer for something that in North America we quaintly call broadband for about 8 years now. And I think they've probably recovered the capital expenditure of building that resource to my house at $100 a month over 8 years or so. But you know, my observation would be that very shortly, I am going to have more bandwidth to my cell phone provisioned over a scarce resource that a telco paid a lot of money for than I get from the local access monopoly via DSL, right? And
how's that?
That seems like a rather interesting, you know, phenomenon, right? I think the local access monopoly on the wire side has obviously not expended, you know, the capital necessary to build resources that are actually useful for us. And I mean, I find it very odd that they don't have more capacity than the wireless vendors seem to be building out. Thank you.
All right. Thank you very much. You guys have been great. I appreciate it.
All right, thank you.